Hi everyone. Does that mic work? Okay. So my name is Kamil. You can reach me through email or Twitter. And welcome to the Refocus talk. Refocus is a one-stop shop for monitoring system health. Let's start about me. In my kind of mid-career, I work in software for around 6 to 7 years. I was a software developer, I was a tester, I was an SRE. So I did a bunch of things. The most challenging, I guess, would be an SRE role. So this is where you put a software developer into an operations world where you have a lot of servers, you have a lot of infrastructure pieces where you could never even heard of. And now this software developer has to do a lot of things under time pressure, quickly. So this was the most challenging one. And I couldn't do any of them, so I moved to management. I moved to the dark side. So now I'm a people manager. I love people, I love technology, so both things work well for me. So before we start into going into details, what is Refocus? One thing from my private life, one thing I would like to share, I love motorbikes. Okay, that's not my bike. I would love this to be my bike. That's my dream bike. It's a Ducati X Diavel. It's a beast. But I have a bike. I'm based in Ireland. If you look at the Google Maps and look at Dublin, I have 5 minutes to the sea and 5 minutes to mountains. So I take my bike, I go to the mountains and relax. Right, so that's me. By the way, it took me 9 years to convince my wife to buy me, so I can buy a bike. So it's not an easy sell. Okay. So I'll tell you a story of how Salesforce went from being small and doing monitoring in a very standard way to grow super big. That's great for business, but you have to scale all of your systems with the growth. And we've been lucky enough to grow really, really quickly to a huge scale. Right now, we're around in 20 or more data centers around the world, which means hundreds of thousands of devices or even millions of devices of different types, servers, network, storage, what have you. So the story starts similar in all companies, and there's nothing wrong with this approach. So first, we start with some sort of data collection, metrics collection. So you might know things like Nagios, things like collectd. Those checks can be on a server and can monitor your server and produce some results, or they can be sort of centralized and perform active checks against your devices. So it usually starts with one small or one big tool. And then someone comes in and says, look, for a network, we have this cool collectd or whatever. Now we would love to use collectd because it's the best fit for network monitoring, right? So we say, of course, we want to use a different tool. We always want to use the best tool for the job. So now you have two things that you have to go look at and check what's the status there, right? So the natural progression from this is to start sending your metrics to some sort of graphs, right? You get some time series database, you get some historical results. You could see that something, let's say a disk space, has been running, it's been increasing ever so throughout the whole week. So now we can see the whole trend, we can do something about it. But what happens on a scale? Well, when you're big, you might have hundreds of thousands of those graphs. And then you start creating dashboards because dashboards are cool, right? You can take a look about the whole piece of your infrastructure, some whole piece of clusters, and dive in. But again, on scale, you might have hundreds of thousands of those dashboards. So how are you going to look at that, right? How are you going to look if something is fine on those graphs, or maybe it's broken? There's not enough humans you can hire to look at all of those graphs. So the next logical thing you're going to do is just set up some alerting, right? Like if some graph is underperforming, and we know the threshold, then you set up an alert, and you just get notified. Again, if you're doing that for 20 servers, you're getting 10 alerts per week, it's all good, right? Everything works. The whole model worked perfectly. Because you get 10 alerts a week, you go to your dashboards, which you have 10 or 5, you find out what's going on, and you react to it. But again, if you're big or very big, you might be getting tens of thousands of those alerts a day, right? So what do you do with a list of 10,000s of alerts? Is everything broken? Is nothing broken? Maybe it's an alert noise problem. Whoever worked with alerting might know alert noise problem. It doesn't go away, it gets worse and worse. Okay, so you might, at some point you might have 10,000s of alerts that are all fake. So if they're fake, people will ignore them. Once they ignore those broken alerts, whenever they become, let's say, real issues, they will still be ignored. So you'll lose visibility because of the alert noise problem amplifies with scales. So once again, this is a very standard approach, collecting metrics, sending this to the time series, doing some alerting. Very standard, works most cases, but at some point it's just everything is too big. Right, so the first big challenge you're gonna get is how would you visualize those hundreds of services that you have? So you have some graphs, you have some metrics, sometimes you might even have some text data like logs, and all you want to know is my service healthy or not? Or is my hundreds of services, are they all healthy or maybe not? So how do you get that from all of those graphs, alerts, dashboards? It's really hard. So that's the first big challenge. The other big challenge is you might start buying a lot of displays for your engineers. You might even start buying big screens in a room so everybody can watch all of those alerts, those graphs. There's so much data, right? So you want to monitor all of that. But at some point, there's just no physical space. Everyone has 6 screens. There's screens on the walls, and it's really hard to monitor that. What you're gonna look at when you look at your alerts, you'll have a big list. Let's say it's 500. Well, again, is everything broken? Is there 500 alerts, 500 things that I have to look at now because they are broken? If that's true, well, we have a real problem. Okay, if that's a real problem, what is it? If I just look at the list, I get a lot of text. But like, where is the problem? How do I correlate what's in the text into a bigger, kind of more abstract way? Maybe this is one cluster that's just shouting at me. But if I look at the text data, it might be really hard to correlate that. So for me as a human, it's gonna be really hard. And if you put people in this environment, they're gonna look like that. And what do? We put our colleagues, we put our engineers and say, here's this 500 alerts, here's all of those graphs. Tell me when something is broken and you're responsible for fixing it, right? So if I'm responsible for fixing it and I can't figure out what's broken and I get 500 things screaming at me, I'm not gonna feel good. I'm not gonna feel good. I'm not gonna go to work every day and be happy. Quite the opposite, right? It's a mission impossible in this environment. And that's what we faced at some stage where everything just grew. We had all systems, all monitoring tools. This is where we were at some point. Not a great place to be. But imagine that someone is really good at looking at monitors. There is 1,000 monitors in the room and someone can see everything, right? They're super good at this. They don't need any help with tooling, they just can watch everything. But they look at this graph here, right? And it says network latency 50. Okay, what is 50? Is this good? Is this bad? Is this what's causing the problem? I can monitor everything, that's what I'm good at, but I have no idea how the network works, right? I have no idea about anything about network. So how do you know that 50 is good? You don't know that from a graph. You're not gonna go to alerts because alerts are or something that's going to tell you, something is broken afterwards. So what actually happens here is you have a lot of knowledge distributed across a lot of teams, but there is no central kind of repo that says, this is okay, this is bad. So it's a really hard problem when you have a lot of things like this, especially when you have a team. We can call it NOC, we can call it an SRE team, but it's essentially a team that monitors everything. And if something is broken, it's going to reach out to the right team, and it's going to try to bring the service back. So if they don't know if 50 is good or not, what they're going to do? They either ignore it or create a false positive. We don't know. So we had to refocus. Refocus is the name of our tool that we created. It used to be called Focus. From, as you can imagine, you see all of those things, you want to focus, you want to have a better view into what's going on. The name Refocus comes from, we had the old tool that we tried to extend, so we couldn't, we just rebuilt it with API first, with the open source spirit in mind. So you can take it, you can use it in your own company for free, we'll give you support. So yeah, it's completely rebranded, new tool that's open source and works well for us. So I'll spend a couple of minutes explaining that. We're solving those problems. So first problem is visibility. Again, you saw all of those graphs, all of those lists of alerts. It's really hard to know as a human what's really broken. We also accommodate a lot of data types. So you can send us something that says, this thing has a warning state. We don't care what warning really means, but we can show you that's in a warning state. It's self-service. So this goes back to the API first design. Everything you do on Refocus, all of the configuration is available through API. We've built some UI to help people to be more user-friendly. But anyway, you still can do everything through API if there's some piece of functionality that you can't. That's one of the challenges on the scale as well. When you have one team owning that small monitoring project, and then that team is being, is very popular and gets so many work items and such a huge backlog that you just can't do anything about it. So adding a self-service option helps, because we can, if you make that easy for users, they're going to do it. They're not going to ask you. And we also scale affordably. And the reason for that is Refocus shows you only the real-time health status. What's right now? What's going on right now? So that means we don't have to store much data. We don't have to store any historical data. That helps. So if you add a little bit more points, real-time data points, it's super cheap, right? We can handle that. So those are the problems we're solving with Refocus. And the biggest one, we can visualize the system health in real time. So you know what's happening right now. And this is particularly helpful, at least for me, when I have a distributed system, a lot of things in a pipeline, a lot of things talk to each other, and something is broken, right? Something is broken at the end of your pipe. It's not serving requests. And now your task is, okay, I've been woken up, middle of night, and I need to figure out what's broken. So in the previous systems, I would have to look at my dashboards, alerts, and try to figure out what's broken. But here I just opened that page, I'm going to show in a minute, and it tells me, yes, here. That's it. That's all work. So that's how it looks like in comparison with those graphs. You can see 3 monitors with graphs on the picture, and they will show less information that you can see in this one small monitor with a bunch of green. A bunch of green means it's good. It's that easy. Green is good, red is bad. So I argue there is more information in this one screen than on those 3 screens, and it's much more than that. Here's a little bit bigger picture of this. As you can see, we kind of group things together. They can represent whatever you want. We represent like different, let's say there's a big cluster that has a group of devices inside, so we're gonna put that as a one thing. And then this big thing will have a lot of more interesting things that we would like to measure, right? And if something, like I said, is bad, it's just gonna be red. So I don't need to know if network 50 is good or bad, because I'm gonna get red or yellow or whatever. So me as an operator, someone who watches that, I've got the big picture straight away. And if you look here, like where is the problem? Like where's the biggest problem? Well, I can see that this piece looks unhealthy, right? Like sometimes I can see some different types of failure, but the A37, whatever that is, looks very unhealthy across the board. So that's broken. I also see that failover, which is a service shared between components, is also broken. So now we have we have horizontal and vertical failures. So I can see, well, the whole service in this cluster is broken, or maybe the whole cluster is broken, right? So different type of failures, and you get visual correlation straight away. This looks more real to what our SREs are looking at. This looks, previously you saw a lot of green, but if I'm responding to things that are broken, I don't care about things that are okay, right? I can just discard them. If they're okay, don't show me. So I'm only showing here things that are failing. And that means that the previous screen, this could have 10 pages, right? It's so many checks, so many clusters, where I just show the things that are failing, everything condensed to a small view. A lot of times, this is almost empty. And that's good, right? Because nothing is broken, we don't have to do anything. And if it's broken, I kind of know exactly what that is. So it's very easy to see that. This is a similar example of this visual correlation. When I was just looking at alerts, I couldn't figure out, but here I see, okay, NA24 is a problem. Everything is broken. So we just did that. We gave this visual coloration to our SREs, right? And the life was good. The whole problem of looking at all of the graphs, everything else, solved, right? You just look at this small thing, shows you good, bad, and then you react. This is our data model, and it's a lot of things on this slide. How are we doing with time? 20 minutes. I might explain just on a very high level. It's important from a perspective that a lot of monitoring systems, they're based on time series data, and we have a different model here. So we have hierarchy. We have a tree model. That means you can build in those correlations that I was talking about you can build that knowledge into a tool. You can say that, something is interesting, and we call it a subject. So whatever is interesting, we're gonna call it a subject. Let's say it's a house, right? We want to monitor a lot of houses. Each subject will have different aspects to it, right? Like a house, you might want to monitor in a house, maybe electricity usage. Maybe you want to see if the windows are open or closed, the lights are on or not. So you have different things you want to measure about the house, so those will be called aspects. And the last thing is a sample. And a sample is something that says, here is the value of an aspect, and this value belongs to this subject. So, for example, the value of windows is closed, and those windows belong to the house 34. And that's it, that's the sample. It shows what's broken, and it belongs to which subject. But now there is this hierarchy that says, well, the house 34 really belongs to a neighborhood A, and the neighborhood A is part of something else. And then you can build that knowledge into your data model. So then when someone says, hey, what's going on in Chicago, they can just look at all of the houses that are under the Chicago subject. So that's our data model. And by the way, Refocus has that model, and you're pushing data and structuring your data in that model. So this way we can have that correlation. Those are a couple of use cases for Refocus, and you might be confused why I'm showing you different things here. Previously, it was just a couple of boxes, yellow, green, but now it's kind of different. I'm going to explain this in a minute, but we support, in the spirit of being very configurable and super adaptable to the environments, we also have different visualizations that we support. As a developer, I can write my own visualization for my own data that visualizes that data in the best way possible. So for example, I can model the process. You can see that this doesn't work. The first, whoa, that's very slow. Okay, so the first image is a model of a process. It's very small, so imagine it's a sales pipeline, right? We all know the sales pipeline where you put your customers through, and it's at different stages, right? So I would like to know that in which stage is this customer, right? I can see, oh, it's a third stage, it's probably very early. But the last one is almost giving us money, right? So it's the right one. Me as let's say someone who deals with money things, I'm gonna reach out to that customer very quickly. So you can see that model, it's visualized, and you can see everyone who is in which stage of it. And it's a similar use case to just an overview or a reporting. So you could condense all of these boxes that you saw before into one box and say, 30% is okay, or 30% is wrong, maybe 100%. So someone like an exec can take a look, and previously I was showing high level. This is very, very high level. This is something for execs, right? They can see, 100% is okay, here's like 50%, or maybe it's 0. Okay, 0, I'm gonna ask why it's 0. So you can pick your abstraction level, but you can really abstract things away and provide like super high level view if you need to. So let's talk about lenses. Lenses are different visualizations of the data. Because we have that standard model, we could build that feature where you can change the way you show your data. So this is our the view, we call it SR grid. Our SREs at Salesforce, they use that. But you could also build something like that, where maybe for your data, geography matters. Maybe you want to see what's broken in Europe. Maybe you're a data center engineer, and you just care about your own data center. So you kind of visualize different geos, and then maybe you can add boxes or however you want to visualize your data. You could do that. Or maybe you could, something like that works better. It's a kind of tree structure with statuses. You could do that too. Or maybe you want to do something like this, which really puts that hierarchy as the first thing you show to people. Let's say we use, by the way, at Salesforce, we use this visual for org chart. So you can see, here's the CEO, here's all his direct reports, and then it goes on and on with all of the people in the team. So if really that hierarchy is the thing you want to show, you would like to use this kind of view. And once you have the data in Refocus, you can keep swapping those views, whatever works for your use case. Just you send different links to people, and they see a different picture of your data. So that's all configurable. We provide tooling for developers to do that. I'll talk about that in a bit. Cool. Let's go to a demo, because the demo are the best if they work. So what I'm gonna do is I'm going to use one of the libraries we provide for developers. It's called LDKey, which is a Lens Development Kit. And what it does, it simulates that environment. It simulates that Refocus environment, shows some data, and we can play with it. So I'm going to run the data generation script. If you can't see that, don't worry, there's nothing fancy here. It's just I'm just calling a script. So that script will generate some data for me. So this is what our SREs see. This is the SR grid, and you can see I'm monitoring the state of the Shire. I want to see Hobbit houses and see how they perform, if that's the correct thing to look at. So I'm looking at if the alarm is working. Do they have battery health? Actually, that's not the right. Let's just look at the simple one first. So the hobbits in North Farding, they have They have a very simple houses. So they'll have only alarms, carbon detectors, maybe some CCTV, some rings, smoke detectors, temperature. So I can take a look at this and see, everything is okay. Maybe if I'm a Hobbit responsible for responding to issues at Hobbit houses, I'm kind of monitoring their houses. I can just take a look at what's broken and figure out what to do about it. So if this house has a really low battery health, I may want to reach out, right? If this alarm, there's like a Hobbit crew that fixes alarms, so I can call them, and they'll go and fix it. So again, what I just did with this hiding is I just hide the whole thing here. So you can see so many pages of Hobbit houses. They're very, very popular. They like building houses. So a lot of them are here. If I look at the failures, this is very easy to comprehend. So imagine you wanted to show a different view. So I'm going to do that to spot a couple of things. Again, I'm running a different script that generated the same data and installed a different view. So if the geography is important, I can see that everything belongs to the Middle Earth, right? There's nothing else there. Maybe there's different words out there, but Hobbit, they don't know about them. If there was different words, I could just add them to Refocus. They will be here. But everything is, as far as we are concerned, everything is in Middle Earth. Then we have the Shire that have Hobbit houses. There is a tag that tells us. The Shire splits into those things, right? So I can see it's a Buckland, it's a Nordfarding. But when I look at here, I can see a tag that shows me a smart Hobbit houses. And this one shows just Hobbit houses. So there's something different. So then when I look at the house in the smart Hobbit houses word, I can see those metrics. Let me check this is the standard. This is too big to show. What's that? That's a start. Smart. Okay. It's not going to be very good, but you can see there's more services in this and less services in that. So for me as an operator, as a Hobbit who monitors houses, I don't care those are two different types of homes, right? If you have like old house, you might have a Hobbit House D system that monitors that house and it works. But if some Hobbits, they're like super conscious about sustainability, they wanted to go for smart home that measures their usage of energy, they have solar panels and all of that cool things, they need a different system to monitor that, right? It's a super advanced technology. So they've installed something different to collect the data. But for me, the Hobbit who monitors everything, I just see, what's the status? Is this okay? Is this broken? So this shows you in a very, very small and simple example how it abstracts so much complexity for the person who is responding to those issues. But imagine, we're just talking about two different things. In technology, we have hundreds of things every day and multiplies this by some scale that you are at, and it's getting really complex very quickly. All right, so we have 15 minutes left. That's good. That means I can show you my baby, my coolest feature of this project that we recently added, and we're in the middle of open sourcing right now. So we're going to talk about rooms and bots now. So this is a natural progression of the workflow. When something is broken in your Refocus, something is red, like what do you do next, right? When alarm detector is broken in some Hobbit house, what do you do? Well, you might want to find someone. First of all, you need a new part, right? You need a new alarm that works. How do you get a new alarm? Well, you have to order it from somewhere. Maybe you call them, maybe there's an API call, maybe there is a website where you order those new things. So that's first thing, get a new part. Someone has to replace it. I couldn't do it, I have two left hands. But even if I could do it, fixing your alarm might not be something you want to do it yourself. So you might want to call some Hobbit group that specializes in alarms. So I just had to do two different things, start two different workflows in response to that red thing on Refocus. So I had to make some actions. And this is what the Refocus rooms and bots are created for. So bots are things that are doing things for us. So for example, in that case where we had to order a new alarm, a bot would be going to a vendor, ordering something from the website, and coming back to us and says, yes, you have it ordered. Wait, 1 day and you're gonna get it. There is a piece where we have everything. We have the crew, Hobbit crew, we have the alarm, and now we have to kind of coordinate. We say, take this, go to this house, and report back. So this is what we call a room. This is where people and bots gather together to collaborate on that response to the event. So if, in the context of software, maybe we can leave the Hobbits alone, that's going to be, things are broken, very broken. Nobody knows what's going on, right? And so but we look at that network, and the network is a little bit slow. So then I'm going to call a network team and say, hey, can you join my call and help us to figure out what's going on? So they join, right? Then they say nothing is wrong with the network. So you're going to say, well, this service looks unhealthy. Let me call the service owner for that particular functionality. You call them, and now you have 10 people on a call, and then you have 20 people on the call, and it keeps going, right? So at some point you have your incident response. That means a lot of people gather and collaborate. And if you did all of that on a conference call, you're going to have a lot of people talking. So that's hard, right? They say you can control a call up to 6 or 8 people. After that, doesn't matter how skilled you are, you're going to lose control of a call. There's just too many people. So that's one challenge. The other challenge is when I'm responding to that big event, that thing that, the Shire is on fire, or my Salesforce doesn't work, right? The whole company is down. That's a big event. So for me, when I handle those events, I have to do something there's a protocol for that, right? So maybe if the service doesn't work, I need to tell the whole company, hey, we're down. If you can help, here's the brief description of the problem. If you think you can help us, join the call and help us. Maybe I have to tell my customers that we're down, right? That's how you build trust. So I might want to send a notification through like a separate system, maybe some status site that tells our customers that we're down. So there's things that I have to do during those very important responses. And if I'm under pressure, if I have 40 people on a call, everybody's screaming, I'm going to forget about it, right? I'm just a human. So having a system that allows you to, first of all, do the things that you have to do, and second of all, tell you, at this point of time during an incident, you should do blah, right? Or at the other time, you should do something else. It's really helpful. So we abstracted the incident management response into creating rooms and bots. So we gather in a room where we have a bunch of bots that are doing work for us, and also we can collaborate. We are meaning humans and other hobbits. Right, so like I said, we are in the middle of open sourcing this, so I don't have a cool slides that are approved and all of that, but I can show you a demo, and I can show you a demo how this looks like on a real kind of incident, real situations when we're under pressure. Something went from really red to a big problem. So that's how a room will look like. And that's a slide. So a room looks like you get one page, and you get status updates from a lot of bots. And we'll go into an example. Maybe that's going to be better if I just show the demo. So that's one of the rooms. Something was broken. And now what do you have to do? Like for us at Salesforce, we have to have like a case. Like we have to log it in some sort of system of record that this happened at that point of time. So here's our case. And cases will have information about the ID, the subject of the problem, description, status, and the impact, like which piece of our clusters are impacted. So we're going to use this case. And under the hood, this is a bot. This is a bot that knows that you want to know the let's say those fields, the subject description. And behind the scenes, it goes to some backend system, and it creates that case, and it gives you that information back. In our case, we use Salesforce to manage all of our infrastructure. So it will go to Salesforce platform, create a case, and show us like what's going on there. So that's our case bot. In the middle, you see a timeline bot. So a timeline is something where I can provide my update. Let's say I've done something for our hobbits. I've ordered some alarm for them. So I'm going to say my update one is blah, right? So I can say this here in a room. It looks like a chat, and people see like what happened when, and we have a nice log of what happens. If you drill down here to events, there is things that we're capturing automatically. So whatever happens on this page, people use a bot to order an alarm, or they use some bot to post a status update. We're going to log it automatically, so you don't have to worry about. Because what's very important after the incident, when you do a post-mortem or RCA or however you call it, root cause analysis, is actually knowing what happened and when during an incident, what kind of decisions were made, at which point of time, and how they impacted the resolution. So we're catching all of these events. We catch users' info as well. So who joined this room, who left, right? So you get a lot of information out of this particular bot. On the right-hand side, we have communications bot. So one of the protocol at Salesforce is to send an update every half an hour to the whole company. Send an update to all of our customers every half an hour. And I have to do it every half an hour. So there's no other excuse. This is our SLA. We provide timely updates during incidents. So I'm going to use this communications bot to define that, to tell me, okay, here's the cadence for this particular update. We call it TCE. And once I do it, once I send that TCE, it's going to start a timer, and it's going to remind me in 5 minutes to the next TCE, 4 minutes, and so on and so on. So I don't have to think about that task, which is something that you have to remember, and it's high pressure environment again. So this is really helpful. Maybe there is some things you always do every incident. So 10 minutes in, you have to check if you have a backup option. 20 minutes in, you have to tell all of our execs. All of those things that are around your incident response, you can just put them here as a timers, tasks, and use the communications bot to manage that. The drop zone bot is for pictures. If I look at the log, I see some graphs. I would rather have that graph in the system than trying to kind of explain what's on the graph, right? Like one picture tells us way more than a lot of words. So I will use drop zone to upload pictures. There is also a participants bot which help us to assign different roles during incidents. So there's always one person running the show. There's always an incident commander who basically runs the conference call and makes decisions on the call. There's someone who is a communications owner, someone who is responsible for making sure the company knows what's going on and our customers know what's going on. There is someone who catches the data, like documentation owner, makes sure that we document everything that's happening for the analysis afterwards. Something like troubleshooting and data mining. Someone has a very specific role to just do troubleshooting all the time. Don't get distracted with anything else. All of this communications, everything else is not important. You just do troubleshooting. So you can assign those different roles to people during an incident, and it becomes really handy when you have 40 people on a call, and you have to say, okay, you're responsible for that. The other person is responsible for something else. It's very clear, very transparent, like who is doing what and when. So that's our participants bot. And the last one is on call. So this is a PagerDuty integration. And if I have a problem with network and application and I don't know, I'm just going to look for a network. And Salesforce is big, so we have a bunch of network teams. But let's say I just call this network team, and I also want some application people, maybe performance application. Right, so I click just page, and what it does, it says, here's that room where people are collaborating, and we need your help. So please go to this room and help us. So it's very simple, and everybody knows where to go. Previously, we had a conference call and a bunch of IRC channels or different, whichever communication tool you use, and people would gather, they would be scattered through like emails, different services, and the chat would happen everywhere. But with room, we say, for the incident, there's one room, and you join this, and let's talk here. So I can click page, and they're going to join. I'm going to get the feedback from PagerDuty that they've received the alert, and they've joined. Right, so again, rooms and bots are a concept that we created, and it's a very generalized way to say, maybe from a different angle. We've used incident management, and then we abstracted what you do during incidents at Salesforce to something that you can do any kind of event response. I can imagine police department, fire department just building their own bots to do what they do and creating that room with those bots and collaborating together. So if you have this kind of use case where you have a bunch of people that need to collaborate and there is some things you have to do, maybe talk to a lot of different external services, this sounds like this functionality. So just to wrap it up, from visibility to actions, that's what we do currently with Refocus. There's one more cool feature that I have no time to talk about, but it's the collectors. We started with push model. We said, we're going to take your data, just give it to us. So they gave it to us. But people wrote a lot of scripts, and they were not reliable. So at some point, we said, well, our customers have reliability issues with getting data to Refocus. So we build a framework for collectors. We provide collecting service for teams. That's a very high-level description. Cool. Right, I always forget to say that. We're open sourced. If you go to Salesforce, github.com, Salesforce Refocus, that's our repo. If you just search in Salesforce repos for Refocus, you'll see a bunch of smaller repos. We provide a lot of tooling for developers. So if you want to write your own bot, you'll have tooling for that. If you want to build your own lens, you'll have tooling for that. You'll have example lenses, example bots that we're in the middle of open sourcing. There's a blog post if you like to read. You don't want to listen to boring talk. So you can just read about it. And yeah, it's free. You can take it, use it at your company, and we're happy to share. Right. Thank you. We have 1 minute.
That was right on time.
Right.
I think we have a little bit time for some short questions, maybe.
Hi. I would like to know, how do you notify colleagues or people that is something going on in this room? Mm-hmm. I mean, they will not always be in the right room at the right time.
Right. So if those are people who are supposed to help you to solve the problem, I'm gonna page them. I'm gonna use the on-call bot to page them on their phone. So they're gonna get a SMS or whatever they like to get, you can configure that. So if you're responsible for a service, you're gonna get a page and you have to join. So that's how we get to know. There's also protocol, but all of the things I'm talking about is the implementation that we've done in Salesforce. So for on-call, we use PagerDuty. For the whole company to know that there is some problem, we send a regular update every half an hour to the whole company and say, here is the problem, here's the room where we try to figure.
Which medium you?
A lot of different mediums. Well, email, and we use Salesforce to run Salesforce. So there is a feature called Chatter, and Chatter is like almost like Facebook, but it's not. I don't want to be on the record saying that. You can collaborate with people using Chatter, right? You can say, add someone, do something. So we use that too for letting know, like a lot of mediums, like the the more the better, because we really want the whole company to know if something is really broken, to kind of get on board quickly, help us to figure out. Yeah.
All right. So Kamil will be around if you have any other questions. One more time, thank you very much for being here. Thank you for this great talk.
Thank you.